Welcome everybody. Today we're going to be discussing stoichiometry. So, first of all, before going to the question we're having here, we have to get the knowledge of what stoichiometry is talking about. Now, first of all, stoichiometry is the aspect of chemistry that deals with the quantity of the product and the reactant of an equation. Now, stoichiometry is mostly used to calculate masses or the mole or percentage of a substance. Now let's start with something. Let's have something like an equation, like we have H2O plus, okay, let's say H plus O2 give us H2O. With H2O. In a conserved reaction, the total masses we have here should be equal to the mass we have here if the equation is conserved. So if the total mass we have is 12 grams, the mass here will be 12 grams. No loss in mass. So now this equation is not balanced. So how do we balance this? We have if you have 2 here, then we'll put 2 here. So now this equation is balanced because we have 4 hydrogen, then 2 oxygen. So this equation is balanced. Now, sometimes in an equation, they ask us to find the moles, the mass, or the percent of substance. Now let me bring our brain to some formulas to solve questions under stoichiometry. Now, first of all, let's take note of mole is equal to the reacting mass over the molar mass of the substance. That's the first formula to note. Now this is to find mole. Now from this equation, if you want to find the mass of the same substance, let's assume you are given mole, you are given the mass or the molar mass of the substance, and you have to find the mass of that substance. You will have to cross multiply. Then cross multiply, we have our mass, which is what we have. Mass will be equal to the mole times the molar mass. Now this is another equation formed from here. It is very easy. Okay, so now let's continue with. All right, so now another formula we should note is mole is equal to concentration, or we can use big M times volume. Now this M is called concentration. Concentration is in mole per dm cube, or grams per dm cube, which any way you like it, or any way you ask. They could ask you find the concentration of the substance in gram per dm cube or in mole per dm cube. So any of the units you are asked for, you have to find it that way. Now I will teach you how to convert from mole per dm cube to gram per dm cube after you're done solving. Alright, so now this is the second formula. This is formula 1, formula 2. Now this is volume. Now this is another formula to note in stoichiometry. Now I'm dropping most of the valued formulas to be used under stoichiometry. So now this is number 2. So number 3, let's say mole is equal to number of particles or number of atoms over Avogadro's constant, which is 6.02 times 10 to the power 23 coulombs. Now this is another formula to calculate moles. Now I've given 3 straight formulas for calculating mole. Mole is equal to mass over molar mass. Mole is equal to concentration times volume. Mole is equal to number of atoms or number of particles over Avogadro's number. Avogadro's number is 6.02 times 10 to the power 23. So now we have another formula which says that, now this is formula 3. Now we have another formula which says molar volume is equal to volume over amount in mole. Amount is in mole here. So now times 100 over 1, then 1000 over 1. Now why we are having times 1000 because if the volume is in cm cube, because most likely your volume will be given in cm cube, so you have to convert your volume in cm cube to dm cube, and to convert from cm cube to dm cube you have to divide the cm cube by 1000, so you get your dm cube. Alright, so now easily just multiply the equation by 1000, you get your volume in cm cube. Now this molar volume here is a constant. It is called 22.4 dm cube. 22.4 dm cube. Now this is a constant for this equation. Now I've given out four equations to note on calculating question under stoichiometry. So I'll bring out molar concentration is equal to mass concentration over the molar mass. Now this is another formula under stoichiometry. This is formula equation 5 or formula 5, and then as well this mass concentration has its own formula, which is mass concentration is equal to amount in grams over volume times 1000. Now this 1000 is when the volume is in cm cube, so multiply by 1000. But if the volume is given in dm cube, you clean up this 1000. All right, so now these are some basic formula you should note on calculating stoichiometry. Now there are some formulas I'll be giving as time goes. Now as I flow through my head, I'll be dropping everything. Like we have this formula, this is 6, so we have this formula as well. Now if you are given some question, they'll ask you if the concentration of a substance is this and the volume is this, what will be the concentration be if the volume is this? Now that type of question, we use this formula CV is equal to K. Now this CV is equal to K. Since CV is equal to K, meaning it is a constant, so therefore C1 V1 is equal to C2 V2, as well as equal to C3 V3 is equal to C4 V4, and so on. So we have it to Cn Vn and so on. So it doesn't stop, it is continuous. So now this is another formula as equation 7. So first of all, let's start up with something cheap. Okay, so now we have this question on the board that we have to tackle real quick and then drop the solution on the board. All right, so how many moles of water is produced when 2.5 mole of hydrogen molecule react with XX oxygen gas? Now first of all, to solve this we have to write the equation of reaction. Now what are we dealing with? They said when 2.5 mole of hydrogen react with oxygen, so we have hydrogen plus oxygen to give us water. Now that's what the question said, because it said water is produced. So water is produced. Now let's check if this it said excess oxygen. So let's assume we have 2 mole of oxygen. So how do we balance this? We have to put, let's put 2 here. If we put 2 here, we have so we have 4. So let's put 4. So we have to change this to 4. So now this is 8 and this is 8. Then oxygen is 4, oxygen is 4, and the equation is balanced. So we have it to be 4:2:4. So let's divide it by 2 to the simplest ratio. So we have it to be 2:1:2. Now this is the ratio we have. So what are we comparing ourselves with? We're comparing hydrogen to water, because they said how many moles of water is produced when 2.5 mole of hydrogen. So they give us 2.5 mole of hydrogen. So we are comparing water to moles. So for hydrogen we have it to be 2.5. So for water it is unknown. Then how many mole of hydrogen here? It is 2. So how many mole of water? It is 2 as well. So let's multiply. We have it to be 2.5 times 2 is equal to x times 2. So we have 5 is equal to 2x. So divide both sides by 2 to make x read the formula. So we have our x will be equal to 2.5 mole of H2O. Now 2.5 mole of water is produced, as the question says. Now that is the answer to the question 1. So now question 2, it said how many moles of oxygen gas is required to burn completely benzene. Now on solving stoichiometric questions, first thing you need to note or know or do in the question is to balance the equation of the reaction. Now first of all, when you write your equation of reaction, first of all check if the equation is balanced before you start solving. If the equation is not balanced, your answer cannot be correct. Alright, so now you say how many moles of oxygen gas is required to burn completely benzene. Now let's bring out benzene structure. Let me teach something. Now this is benzene. I'll write benzene in 2 forms. This is benzene. Benzene can be in this form, or benzene could be in this form. Now at each point is a carbon atoms. Carbon as well, carbon. Now a single carbon can bond to 4 different or 4 similar compounds. Okay, so now the maximum number of bonds in carbon atom is 4. So now we already have 3 bonds to each carbon. We have, for this carbon, we have 1, 2, 3. So we are left with 1 hydrogen, because this is an hydrocarbon. So hydrocarbon are compound that has just hydrogen to carbon bond. Now if there's another element attached to this hydrogen to carbon bond, let's assume oxygen or nitrogen, it is no longer an hydrocarbon, it is just called an organic compound. Now organic compounds can be hydrocarbon, but hydrocarbon cannot be organic compound that has a constituent different from hydrogen and carbon. Okay, so now this is an hydrocarbon. So we have here 1 hydrogen. Then we have, for this carbon, we have 1 bond, 2 bond, 3 bond. So we have just 1 hydrogen as well. So the same thing goes to here: 1 bond, 2 bond, 3. Then the last one, 4. 1, 2, 3, 4. 1, 2, 3, 4. So now this is 4 hydrogen. 1, 2, 3, 4, 5, and this one as well, 6. So we have 6 hydrogen, and as well we have many carbons: 1, 2, 3, 4, 5, 6. So we have 6 carbons. So now the structure, the chemical equation, the chemical formula for benzene is C6H6. Now this is benzene, C6H6. Now they said if it is bond, how many moles of oxygen is needed to bond this benzene. Now let's bring out the structure. So we have C6H6 plus oxygen. What would the equation be? What would the product be? Now remember or recall or note that when you burn hydrocarbon in oxygen, the product you will always have is H2O and O2, CO2, water and carbon dioxide, the carbon dioxide. These are always the product when you burn an hydrocarbon in air. Okay, so now burning hydrocarbons in air has a formula now, and that formula is called the combustion formula. Now let's take this. If we have let's use here CXHY plus this X will be here, X plus Y over 2, then O2, which is the oxygen, this is carbon, this is hydrogen, this is oxygen, giving us Y over 2 H2O plus Y over 2 H2O plus XCO2. Now this is the equation for combustion of hydrocarbons. Now let's use this formula to balance this. You understand it so clear and plain. So we have 66. Now let's balance it to get CO2. Now let's go. So we have C6H6 plus. So for this oxygen, this is the formula, and this formula contains the X and the Y. So now let's take the X from here. So we have X to be on carbon, so we have 6 plus, then for this one we have 6 over 4, then O2. So we have for CO2 we have X, which is 6 CO2 plus, for the Y we have 6 as well, so we have 6 over 2 H2O. Now let's do the summation here. So we have 6 plus 6 over 4, 6 over 4. So we have let's take the LCM direct. So we have 4 over 1 divided by 4, we got 4 times 6, we got 24. Then 4 divided by 4 will give us 1 times 6 will give us 6. So we have 30 over 4. We have 30 over 4. So over here we have 6 divided by 2. 6 divided by 2 is 3. So now let's rewrite the equation. Now this equation is having a 2 here, so we have it to be 2C6H6 plus 30 over 4 O2, then 6 then plus 3H2O. Now since in this formula they didn't indicate, or they didn't tell you that if they didn't use any mole of the compound, the organic compound, then let's assume we are having 2 here, we're multiplying every side with a 2 apart from this. So if we have 2 here, 2C6H6 plus, so 2 times 30 over 4. So if we have 2 times 30 over 4, so we can cancel out. We have 1, then we have as well we have 2 here, so cancel out here, we have 15. So this is 15. So here we have 15 O2. So over here we have times 2, we have 12 CO2. Then H2O times 3, 2 times 3 H2O, we have 6 H2O. 6 H2O. So now let's check this equation is balanced like this. So we have 2 times 6 will give us 12 carbons. Then here we have 12 carbons as well, so carbon is balanced. Then hydrogen, we have 6 times 2, which is 12. Then for hydrogen here, 6 times 2 is 12 as well, so hydrogen is balanced. Then for oxygen we have 15 times 2 give us 30 oxygen. Then oxygen we have 12 here, 12 times 2 give us 24. Then for over here we have 1, so H2O, so oxygen there is 1 times 6 will give us 6, so we have it to be as well 30. So therefore this equation is totally balanced. From what we have here, it is totally balanced. Now I'll be doing a video and I will be sending the link, or I'll be posting it on this YouTube channel, then post the video to you all to go watch how to balance equation. Now I'll be doing the video after this class. Okay, so now this is the balance equation of combustion of benzene. Now the question said how many moles of oxygen gas is required. Now if you have any type of question on your JAMB or post-UTME, so they're asking you how many moles could burn this. The actual answer is 15 moles I could burn 2C6H6. So the answer is 15 moles. And this is the answer, 15 moles. 15 moles of oxygen. Now this is the answer. Now let's try to tackle another question. Let's solve other question on our stoichiometry.